Hi, my name is Nasira Nelson. I'm a student in the independent section of Technology Design Foundations. My project is called OpenHand, Rethinking Accessible Design, and in this video, I'll walk you through my design and what I learned through the process. My project, OpenHand, is a 3D printed, articulated robot hand that can grasp, pinch, and perform simple gestures. I began with an open source design from Ubonics as a way to learn the fundamentals of robotics while documenting my process so others could follow along. At its core, OpenHand is about rethinking accessibility in robotics, not just providing files and instructions, but making designs affordable, adaptable, and approachable for new learners. My goals were twofold: to use the build as my entry point into robotics and to explore how open source designs can be improved to create more access for others. I'm especially interested in hardware for AI, and I see robotics becoming increasingly important as these fields advance. Like AI, robotics is moving quickly, and if we don't start exposing people early in relatable ways, many risk being left out. OpenHand was my small step towards bridging that gap. My system is powered by an Adafruit ESP32 Feather V2 microcontroller, paired with a servo driver that manages 6 microservos, which control the fingers. I decided to include an ultrasonic distance sensor and a PIR motion detector to give the hand multiple ways to sense its environment. The whole setup runs on a 5-volt power supply, and everything is connected with jumper wires. To make all the components fit, I desoldered the male header pins and replaced them with female headers. This let me stack the ESP32 with the feather wing. Since I'm powering 6 servos, I added a terminal block for a separate 5-volt power source. The sensors also draw from the same power supply, but compared to the servos, they use very little power, so the system is still pretty efficient. Let's just say I ran into a lot of problems with this build, definitely more than I expected. The paint-by-number style instructions turned out to be a lot more complicated in practice. For example, I had to fabricate a servo horn that wasn't included in the original design, which really slowed me down. My soldering skills are pretty basic at best, so I had to learn how to desolder when replacing the header pins, which was a huge time sink. Luckily, there were design specialists available to help when I felt stuck or just running out of energy. I also made the choice to deviate away from the original instructions and use the microcontroller I already had. That meant a lot of extra legwork figuring out how to integrate it. I don't have much experience with the Arduino IDE, and I ran into a lot of issues getting the board to show up. Fortunately, Professor Jeff helped me get back on track, and I was able to get the board talking to the servo driver and servos. I also had some trouble locating sample code for the servos. Professor Jeff also sent me a link to some sample code from the Adafruit website. But by then, I was running short on time and I needed to wrap things up and start my video. I knew I was going to need a lot more time to refine and edit the code, especially as it relates to calculating the PWM values that would tell the servos to move the fingers smoothly without breaking the parts or burning out the motors. So while I got the system partially working, more importantly, I came away with a deeper appreciation for the complexity of even so-called simple robotics projects and how much patience and iteration is required. I originally took on this project because I thought it would be cool to develop a robotic farming hand, something that could eventually be paired with AI to help with various farming tasks. My idea was to build arms on an XY grid with a tool changing system so different hands could be swapped out depending on the job. As you can see, I'm still a long way away from that original vision. Along the way, I had an impactful conversation with Professor Jeff that made me realize I might be missing the deeper point of this class. I'm really grateful that he gave me the space to pursue this project because he could see it was important to me and that I needed to follow it through. Looking back, if I had the chance to start over, I might have chosen a different direction, one that leaned more into my own design explorations and reflections, especially around what it means to create emerging technologies.